In 1989, humanity came closer than ever before to realizing how fragile its existence really is. On March 23rd, a space rock nearly 300 meters wide, named Apophis, swept past Earth at a distance of just 700,000 kilometers. It was not a near miss by chance. It was a near miss by luck. 6 hours earlier, our planet had been exactly where that asteroid passed. Had it arrived just a few hours sooner, or slower, the outcome would have been catastrophic. Not an extinction-level event. Not yet, but enough to erase a continent, to burn cities, to darken the sky for years. And we didn't even know it was coming until after it had passed. That day, we stopped thinking of asteroids as distant, harmless objects. We began to understand they are not visitors. They are waiting, and one day they will not miss. The asteroid, now known as 99942 Apophis, named after the ancient Egyptian god of chaos, was discovered in 2004. But its closest approach happened long before that. In 1989, it flew past Earth without being detected. No telescope saw it. No radar tracked it. It slipped through the safety net of human observation like a shadow. Its size, about 370 meters across, means that if it had hit, it would have released energy equivalent to 1,000 megatons of TNT. That's more than all the nuclear weapons on Earth combined. It wouldn't have ended life, but it would have ended civilization as we know it. Forests would have burned across continents. Tsunamis would have drowned coastlines. Dust would have blocked sunlight for years. Agriculture would have collapsed. Billions would have starved. And we wouldn't have seen it coming. Not until it was too late. Apophis is not alone. It belongs to a group called the Apollo asteroids, objects whose orbits cross Earth's path. There are over 28,000 known near-Earth objects today. More than 2,000 of them are larger than 1 kilometer. And that's only what we've found. Scientists estimate there could be another 10,000 undiscovered objects larger than 140 meters, big enough to wipe out a small country. The most dangerous among them is not Apophis anymore. It's 29075 1950 DA. This asteroid has a diameter of 1.3 kilometers, a mass of 2 billion tons, and a speed of 18 kilometers per second, faster than any human-made object has ever traveled. Its orbit brings it dangerously close to Earth every 2.21 years. The next potential impact? The year 2880. That sounds far away, but here's the truth. When you're talking about orbital mechanics, far away means nothing. Even a tiny change in its path, caused by solar radiation, gravitational tugs from other planets, or even the Yarkovsky effect, can shift its trajectory by thousands of kilometers over centuries. The odds of impact in 2880 are currently estimated at 1 in 8,300. Small? Maybe. But when the cost of failure is global collapse, even a 0.01% chance is too high. When an asteroid strikes Earth, it doesn't just crash. It explodes. At 18 kilometers per second, kinetic energy becomes the dominant force. The asteroid compresses the air ahead of it like a piston. Heat rises to tens of thousands of degrees. The surface vaporizes. The atmosphere ignites. The impact creates a crater dozens of kilometers wide. 429075. The energy released would equal 75 gigatons of TNT. That's 1,500 times more powerful than the largest nuclear bomb ever tested. The shockwave would travel around the globe multiple times. Seismic waves would trigger earthquakes along fault lines already under stress. Volcanoes might erupt. Tectonic plates would shudder. The ground itself would ripple like water. Then comes the firestorm. Dust and debris thrown into the stratosphere would circle the planet within days. Sunlight would dim, temperatures would drop, photosynthesis would stop, food chains would collapse, the oceans would acidify, oxygen levels would fall, civilization wouldn't end instantly. It would fade slowly over years, and no government, no army, no technology could stop it once the impact had begun. Earth is not new to this. The fossil record tells us that large impacts have occurred many times. About 66 million years ago, a 10-kilometer-wide asteroid struck what is now the Yucatan Peninsula. It triggered a chain reaction. Wildfires across continents, tsunamis taller than mountains, acid rain, and a decade-long winter. 3/4 of all species died. Dinosaurs vanished. But life didn't. Mammals survived. Small, adaptable, hidden. And over millions of years, they evolved. Into primates. Into humans. We are the children of cosmic catastrophe. Every mass extinction, including the Permian-Triassic event, which wiped out 96% of marine life, likely involve an asteroid or comet. Some scientists believe the origin of water on Earth came from icy comets. Others say organic molecules essential for life. Amino acids, sugars, were delivered by carbon-rich asteroids. So while asteroids kill, they also create. They are both destroyer and midwife. And that duality makes them terrifying and beautiful. Asteroid impacts aren't rare. They're inevitable. Geological records show that objects larger than 1 kilometer strike Earth roughly every 500,000 years. Objects like Apophis, hundreds of meters wide, hit every 20,000 to 50,000 years. Smaller ones, city killers, strike every few centuries. The last one was in 1908, the Tunguska event. An asteroid, perhaps 50 to 60 meters wide, exploded above Siberia with a force of 10 to 15 megatons. It flattened 80 million trees over 2,000 square kilometers. No crater, just destruction. And no one was killed because no one lived there. If it had happened over New York, London, or Tokyo, millions would have died. And we still wouldn't have known it was coming. Today, we have telescopes. We have computers. We have international networks tracking near-Earth objects. But we don't have a plan. Not a real one. Not yet. NASA's DART mission changed everything. In September 2022, a spacecraft deliberately crashed into Dimorphos, a small moon orbiting an asteroid, and altered its orbit by 33 minutes. It was the first time humanity ever moved a celestial body. Proof that planetary defense is possible. But DART targeted a small object. What if the threat is 29,075? Or worse, something bigger, darker, undetected? We need early warning. We need deflection. We need redundancy. We need to launch missions decades before impact, not months. We need space-based telescopes that can scan the entire sky, not just parts of it. We need international cooperation, not politics. Right now, only a handful of countries have active asteroid detection programs. Only one, NASA, has successfully tested deflection. The rest are watching, waiting, hoping. That's not a strategy. That's a gamble. The biggest threat isn't the asteroids we know. It's the ones we haven't seen. Most of our telescopes look outward, toward the stars. But the real danger comes from inside. From the direction of the sun, objects approaching from that angle are invisible to ground-based observatories. They slip past us in daylight. We call them sun grazers, and we have no system to detect them. There may be dozens of kilometer-sized asteroids currently circling the inner solar system, hidden in the glare of our own star, moving silently toward us. One of them could be on course right now, with no warning, no time, no chance to react. And if it hits, we won't even see it coming. The explosion would blind our satellites. The dust would block our view. By the time we realized what happened, it would already be too late. Earth has endured 5 mass extinctions. Each time, life adapted, rebuilt, evolved. After the dinosaurs fell, mammals rose. After ice ages ended, forests returned. After volcanic winters faded, oceans warmed again. But none of those events happened because of intelligent life. None of them were preceded by warnings, simulations, or debates. This time, it's different. We know what's coming. We've mapped the skies. We've calculated the risks. We've built the tools. And yet, we do nothing serious. We fund entertainment. We build weapons. We argue over borders. We ignore the sky. We act like extinction is someone else's problem. But it isn't. It's ours. And if we don't act, not in the next 50 years, but now, then future generations won't curse us for our ignorance. They'll simply vanish, and no one will remember we were ever here. An asteroid doesn't hate us. It doesn't want to destroy us. It doesn't care. It's just physics, gravity, motion, time. It follows rules older than life, older than Earth, older than the sun. And if we don't learn to control our place in those rules, we will be erased by them, quietly, suddenly, and without drama. We are not the center of the universe. We are not special. We are not immune. But we are unique in one way. We're the only species on Earth that knows it might die because of something falling from the sky. And we're the only species that can do something about it. We can build the shields. We can launch the probes. We can train the engineers. We can fund the science. We can choose to survive. Or we can wait and hope and pray that the next one misses. Again, but hope is not a strategy. Knowledge is, action is, and time is running out. We hope this journey ignited your curiosity. Stay with us as we explore the silent threats lurking beyond our atmosphere. Subscribe and join us for the next discovery.